Hello and welcome to yet another episode of ENTECH Online Daily News, where we explain tomorrow's technology today. We have just come across a very fascinating research, and just imagine something like this. You have a swimming pool, there's a water in the swimming pool, and then there is a dew which falls in the morning. So this is water in the swimming pool, dew is also a water. Does it behave in the same way? No, scientists have identified that it doesn't behave in the same way. And that is the research breakthrough. So joining us is Dr. Pathak. And if you can explain us, sir, what is the research telling us?
Thank you, sir, and welcome again. So this is like a research wherein scientists they were facing a trouble in identifying the properties of a water droplet, or we can say a dew,
Okay.
a tiny water droplet, and it behaves differently than the bulk water or water in the swimming pool. So to analyze the properties of this small droplet, they
You have to
have
catch it.
created to
You
catch
have
it.
to catch it. How do you catch that droplet in a droplet form? You have to catch it. So how do they catch it?
So they leviated the water droplet. It's like it's a electrodynamic balance you can imagine, and they apply that specific DC voltage so that you get a pull force. Okay, so that it acts against the gravity and it helps to leviate the water droplet.
Okay. So it's like suspended in an electrical field, right?
Yeah, it floats safely.
It floats safely. Yes. And then what happens?
Then to study it, they need a spectroscopy, and for that what they do, they fire a laser with some specific frequency, and because of that water droplet that it gets heated, and once it gets heated, then it loses weight because of small evaporation, of course a very small bit of evaporation, and this is enough to for a water droplet to shift upward. And then essentially they measure the shift using the technique they had developed, Siddhi-Ras.
So can you please tell us or spell us what is this technique? What is it called?
Yeah, it is like a Siddhi-Ras. Siddhi-Ras, it's like a manifestation of their work, and the single droplet infrared analysis system, they call it.
Okay, so it is SIDDIRAS. So that's the technique which has been introduced new, and that's the breakthrough.
Yes. Yeah, that is the breakthrough. That is the breakthrough. Yeah.
Yeah, that's the breakthrough. But in chemistry, we study bulk solutions, solvents, solutes in the chemistry classes and even in the industry. So does this tiny floating droplet behave in the same way as a regular beaker of salt water?
No. So it behaved completely differently. So that's a major finding. That is a major finding. And normal salt water has a fixed saturation limit. Okay, but micro droplet, it can become highly supersaturated, so far beyond the normal limits. So that is the finding. So how they then, because of this leviating environment, it forces these chemicals to behave differently.
Okay. The study also mentions about hydrogen bonding network, right? So what is it? And we keep on measuring these droplets. How does it help us to understand these molecular bonds?
So they basically they use infrared spectroscopy for this, which is extremely sensitive, and adding salt that weakens the hydrogen bond. So that's why you measure that displacement, tiny displacement.
Okay, but it's okay. I mean, we have done all these things. We did study molecules. we studied hydrogen bonds, everything. How does it help in real world?
Yeah, these phenomena we can like better understand the cloud formation basically. So if you
Okay.
understand the property at micro level or single drop, then you can use this knowledge or the result
Okay.
for understanding or better understanding cloud formation. So it has direct impact on your environmental sciences. You can like even measure pollution reactions because of this information, and you can refine the climate models they are present. So it's a huge benefit to our day-to-day, even day-to-day life.
Okay. So in last 4 or 5 minutes, I heard a lot of keywords. So let me just repeat. You talked about levitation. You talked about hydrogen bonds. You talked about applying forces. You talked about displacement. You talked about clouds. You talked about uh, environmental sciences, and so on and so forth. Right. So it seems to
Yeah.
me that everything gets combined, all put together. So what should I study, sir, as a student?
Uh, I would recommend to our friends in 12th or 11th class, they should
Mm-hmm.
devote more attention to electric fields, spectroscopy, thermodynamics, water properties, hydrogen bonding, to name
Okay.
a few.
Mm-hmm.
And another thing is like they should stay curious.
Okay.
Yeah. So curiosity is like very important so that they can find the intersection of all these three different sciences.
Okay. So this is kind of a interdisciplinary or multidisciplinary field, right?
Yes, yes.
Okay. So tell me in some domains which I should be studying into in university or in colleges.
Yeah, a team can like explore passion in physical chemistry, analytical chemistry, environmental chemistry. So it's a wonderful intersection of all these different fields. And
Right.
definitely someone who is like interested in electronics. So
Mm-hmm.
sensors and preparing instrumentation, analyzing the data. So data analysis is also there in this study. So
Okay.
a lot of fields. This research is helpful for a lot of fields. So team can plan their education and career in this field.
In this particular field, right? So
Yes.
lastly, just summarizing, Dr. Pathak. So if the students are interested in knowing weather patterns, if they're interested in pollution tracking, if they're interested into analytical chemistry, if they're interested into electrical fields, and so on and so forth, they can uh, ultimately go and solve the real world problems. So thank you so much,
Yes.
Dr. Pathak,
Yes.
for joining us, and
Thank you,
see you
sir.
next
Yeah.
time. Until
Thank
then,
you.
start studying. Thank you.
Yeah. Yeah. Please subscribe to our channel, ENTECH Magazine. Thank you.
Thank you.